It is my pleasure to introduce our first speaker today, Arquemino Lopes from OEM Global Key Account Management at Festo, Germany, who will share with us his insights on how digitalization meets automation.
1, 2, 3. ¿Me escuchan todos? Buenos días. Good morning, everybody. Ladies and gentlemen, my name is Arquemino Lopes. As Vita already introduced me, I work at the company Festo. I'm responsible there for the issue regarding the global key account management in the OEM area, machine builders. So, Festo is most known in the pneumatics area, but we are also a complete supplier for the whole automation program. It means we have also electrical automation components in our programs, and last but not least, we are offering our customer also robotic solution. So that's because since we have many different technologies in our portfolio, we started some years ago to think about the big issue, Industry 4.0, digitalization. But we found that these big words, Industry 4.0, digitalization, are or have a great or a big meaning. So it's a word inside of these words. And what is this actually? Digitalization in the automation. So the mankind is a very intelligent creature, but we are also a very lazy one. It means we let others work for us. And that was the motivation for mankind to improve the way to produce the products or the means we need to live. Everything started 200 years ago, more or less, when we discovered that nature could work for ourselves. And we in the textile industry have started with the whole thing, with the first steam and water-moved machines. The first spin and web machines at that point in time were moved by steam. And that was the first big step in the direction we have today in the so-called digitalized world. After that, at the end of the 19th century, more or less, we have discovered another phenomenon, a nature phenomenon, which was electricity. And then we found out that electricity could help us to produce the same things in very big amounts and very big quantities. And that has made it possible to produce things in mass production scales. So that was the second step in the so-called second industrial revolution. And at the end of the 60s, at the beginning of the 70s, we have discovered that electricity could be used in a very small chips that could help us to deal better with numbers. That was the beginning of the computing, of the so-called programmable controllers. And that was the so-called third industrial revolution. And now, at the beginning of the 2000s and the current days, we are experiencing the era of the digitalization. The so-called Industry 4.0 is marked by the issue regarding digitalization. It means we are dealing with cyber-physical systems. We are using internet to produce in a more effective way. We are using portable equipments to manage our production. So, as at the beginning, we used steam and water, which has made it possible to work in a more efficient way. And with electricity, we got the event and the phenomenon of mass production. And that has led us to develop computers and programmable controllers. All those things has led us today to the issue regarding digitalization in the automation. So, the main difference between the so-called third industrial revolution with the large use of programmable controllers that has made it possible to make a kind of central controlling of the production, and the so-called fourth industrial revolution, or the Industry 4.0, is that the control task is not made anymore in a central way, but now the control task is made in a kind of network, decentralized, because we are able to use portable equipments to manage machines, to control machines individual machines, or even complete production lines. And digitalization or digitalized systems are the key to make this decentralization of the production control. So, at the beginning, with the issue regarding the digitalization, we started to feel what digitalization means in our lives in the side of the B2C world, B2C, business to consumer. So we started to buy things online, to use internet, to change the way in which we do our buyings. And this has led to a development of a certain platform, a certain structure, that is being used today in the world of industrial production, in the so-called B2B world, or business to business. The platform and the central structure is a digitalized structure, in which we use, for example, cloud computing, in which we deal with this big amount of data in a more intelligent way, in which we can prepare this data to the operators in order to get to a more productive way in terms of decision-making, predictive maintenance, for example. We will see a little bit later that all this digitalized structure has led machine builders, end users, and mainly suppliers of automation components in a new way to develop products and solutions to make production systems more intelligent. So we at Festo, we started to use the facilities and the features of this new digitalized world in order to develop our products based on the requirements of the machine builders, of the so-called OEM side, but also based on the requirements of the end users, of your customers. So we are giving our customers, we are selling our products mainly to machine builders, so that they can use our products to make their machines more intelligent, more efficient, so that their customers, the so-called end users, can make use of the great features of digitalized production systems. So we at Festo, we consider 4 big blocks in the development of our products and solutions. At the machine building side, we start with the digitalization adventure with tools that make the task regarding the engineering faster, better, and user-friendly, more user-friendly. Since the solution is engineering, these components have to be installed. And we try to give our components features that make the commissioning task faster and clever. And in the side of the end user, we give our components and our products features that can make the life easier regarding operation and maintenance. And these 4 blocks are 4 blocks that must be considered by each automation supplier. We Festo are one of them. We consider ourselves as enablers of the digitalized world. But if we think only at the machine builder side, we will never reach the end users that at the end are those who decide to buy a machine and the other way around to buy our components. And that's the way automation suppliers are thinking nowadays. So I think I got a microphone here. So just to illustrate a little bit more, these 4 blocks. In the R&D chain at Festo, as mentioned, and we started the digitalization adventure with software tools that make the task regarding engineering and projecting machines much easier and faster. These software tools are, most of them, for free. Machine builders can use them online in order to project and engineer the solution much faster. The components itself, they got a known intelligence. So we have thought about how to make a simple pneumatic actuator intelligent. We can make it in different ways. The first and more simple way is to give sensors to them. so that we can know all the time where this actuator is positioned. So, intelligence at the actuator level is also a key issue to make machines and production lines more intelligent, more efficient. And since the components are already installed, we have to integrate all these single actuators, all these single components in the whole solution. That's because, as automation supplier, we have to give our customers the possibility to integrate all the solutions in a single one platform, in a single automation suite. When the solution is running, then we are talking about the features of digitalized products at the side of the end users. So the end user or the operator has to have the possibility to control digitally the application at the actuator level. It means collect data from the actuator, base it basically on intelligent actuators, send this data to a central platform, which can be a server or even a cloud-based service, and get those data back in a prepared way in order to take decisions regarding, for example, maintenance, predictive maintenance, or production optimization, dimension changes in the product, and so on. Everything begins with the engineering tasks and ends at the decision-making process at end-user side based on the data analysis we can make by analyzing those data that we can collect from the actuator level. So this figure, I don't care about the details, but I just would like to give an overview or try to illustrate the so-called automation pyramid. So in this automation pyramid, we have in each automated solution, everything begins with the actuator level. So we have here in this level, pneumatical cylinders, electrical servo motors, stepper motors, different actuators that make movements, linear or rotatory movements. And this is where the automation is made. So it will not change. We need certain standard components to make things move. But this movement, they have to be controlled and managed. A simple pneumatical actuator, a simple pneumatical cylinder, can be equipped with sensors so that we can know all the time where this actuator is positioned. In the second level of this automation pyramid, we have the so-called control level, basically the PLCs of this world. Actually, Festo, as I said, is most known as a pneumatics supplier, but we have also the complete electrical automation program, also PLCs in our product portfolio. And this second level, the control level, is responsible to prepare data of the actuators level in order to send this data to a central platform. In this case, we illustrate here a cloud, which could be a Festo cloud, or a third-party cloud based on the Microsoft Azure platform, or even a cloud of other automation suppliers, here, for example, Siemens or Rockwell in America. It means that Festo is not only supplying or offering pneumatical solutions or electrical automation solutions. We are, together with other important names in the automation world, giving our customers the possibility to make their machines more intelligent, in which they collect data from the actuator level, send this data in a prepared way to a cloud. In this cloud, we can develop, together with our customers, the so-called cloud-based services in order to prepare this data so that this data can help the operator to take the right decisions in terms of operation, maintenance, and production administration. So, in order to do that, we have to follow some standards. For example, in the communication with the cloud area, with the cloud level, we work with the so-called OPC UA protocol. That is a standardized protocol for every gateways that send data from the automation level to the cloud level. So we have also products and solutions in that area, with the so-called IoT gateway. IoT stands for Internet of Things. And based on this big amount of data, we can also develop solutions, specified and specific, customer-specific solutions to show this data in a prepared way on the cell phone, on a tablet, or even on the HMI. And we are not alone. So we, as automation supplier, we work together with different automation suppliers in different areas in order to come up with a common solution to our customers. So, and which kind of data can we deal with these so-called cloud-based services? So we can deal with parameter data. We can parameterize and store those parameter data in a central cloud application. It's possible to analyze process data as well, the data that we are collecting from the sensor level. We can know exactly which kind of products are installed on a machine or in a whole factory based on the so-called asset data digitally. And last but not least, and here comes the biggest effect of digitalization in the industrial automation, we can deal and make smarter data available to the operator, in which the operator can do, for example, very fast and intelligent condition monitoring administration, so that the operator can know exactly how is the status regarding performance and life cycle of each actuator on the field. It can be a pneumatic cylinder, it can be a servo motor. Everything that moves can be analyzed, can be controlled, and can be used as a variable to take decisions in order to make the production more efficient. So, another big issue for us and for each automation supplier is regarding the effects of the use of artificial intelligence in the automation. And this is another result of the digitalization. So digitalization in the automation has led us now to the big word of it, artificial intelligence. We have made the question, what if we put a certain artificial intelligence software module inside of a servo motor drive that can monitor all the time the current consumption, so that I can get alarms direct from the electrical drive in case that the current consumption changes. We can monitor, for example, eventual mechanical problems on the axis. If the motor starts to consume in a sudden way more current, it can be a signal for me as operator that this motor is making much more effort to make the same task. It can be that I have a mechanical problem in my axis, or increased friction. Maybe a product that should weigh just 10 kilos has been made in a wrong way and has a weight of 11 or 12 kilos. I can detect this anomaly directly on the edge. On the edge stays for artificial intelligence functions used directly on the component. In this case that I have said, it would be the electrical drive, equipped with artificial intelligence module. And the advantages of it for the machine builder is the reduction of programming efforts. I don't have to have lots of sensors installed on my machine. I just have to develop and equip certain components on my machine with artificial intelligence functions. So I reduce the complexity of my installation. And for the end user, I can prevent production stops, for example. Another aspect of artificial intelligence is the so-called on-premises artificial intelligence. I can install artificial intelligence functions directly on my PLC. The PLC can take decisions in an automated way, analyzing data that I'm collecting direct from the sensor level without having to ask the operator for that. That is the so-called on-premises artificial intelligence. And the third way to integrate artificial intelligence in the automation is to equip the so-called the cloud-based services with artificial intelligence functions in the cloud. So on my server, on my cloud application, I can program artificial intelligence tasks that can monitor and take decisions for me in order to make my production faster and more efficient. And now those things will work only if the actuator level is equipped with a certain intelligence. And that's the message that I would like to let here. That's my last slide. Festo, as a supplier of automation components, we start our digitalization adventure in the automation in the actuator level, in which we give intelligence to our actuators by using sensors on it. But that is only the very beginning. Collecting this data, we can aggregate this data through different components, transmit this data in a standardized way to the cloud, to a cloud-based application. We can store this data in this cloud-based application, and on the server, where the cloud-based application is running, we can do the so-called statistical analytics. It means prepare this big amount of data to the machine builder and mainly to the end user to derive actions based on the behavior of the system. So my message for you is digitalization is not a destination. It's just a way to make machines more intelligent, more efficient, and more productive. And Festo, as an automation supplier, mainly in the actuator level, is one of the enablers of the big issue regarding the digitalization. So, if you are curious about it, you can visit us here in the Hall 7, booth C123, and there we are showing what we can do in a practical way regarding the big issue Industry 4.0 and digitalization. Thank you so much for the time, for the interest. And now we have some time for questions. Huh? Thank you.
Any questions to our speaker?
Thank you very much. Congratulations on your presentation. I would like to ask you if your gateways are prepared to deal with legacy machines and older PLCs.
Which kind of machines? I didn't
IoT gateways are prepared to deal with legacy machines and older PLCs.
Yeah. So this small box here, called Internet of Things Gateway, IoT Gateway, is a small box that collects the big amount of data from the different sensors from the machine and transforms it in a standardized communication, let's put in these words, so that I can transfer this big amount of data in a standardized way to the cloud. It means the answer for your question is yes, we can do it, because from this point on, all the communication with the cloud is standardized. So the only test that I have to do is send those data from the actuator level in a form that the Internet of Things Gateway can collect them and send it to the cloud. Is yes. The answer for your question is yes.
Hi, thanks for your presentation. One question regarding the data, the data selection or the data types that you mentioned. You mentioned process data and smart data. Mm-hmm. What is the difference between the two?
So let's go back here to the slide. Oops. Yeah. So process data is what is happening, what is running. I don't analyze anything. I just get the signals as they are coming to me. If the actuator has left the initial position or has arrived at the destination or not, that is what we mean process data. We just collect the data that are running. Smart data, in our understanding, is a kind of prepared data. We collect this running data, and we prepare them based, for example, on a history. So you can monitor electrical servo drive in the time for years. And if you have a fixed process, you know exactly what is the average current consumption of certain electrical drive for the specific axis. If you monitor this during the time, you can identify some points where the current consumption has a big gap or has increased. It can be normal, but it's for you an alarm or a signal that something strange is happening with that axis. And we call smart data the analysis of these peaks. So we can get the history and prepare the analysis, for example, in this example, of those peaks in a prepared table or in a prepared graphic showing these peaks to the operator, so that the operator has the chance to analyze these peaks regarding the current consumption of a certain electrical drive and take decisions. It can be a normal situation, but it can be an alarm that something is going wrong in the application. That's what we call smart data. Data regarding decisions, regarding the condition monitoring tasks that we have to do, or the operator has to do in every single machine.
Okay, thanks.
Okay, people, thank you so much once again. I hope to see you here at our booth, and I wish you a very successful ITMA 2019. Thank you. Bye.